Right, one of the more kind of difficult exponent rules. Well, it's not really a new rule, it's just something to get your head around. Okay, so, now then, think about this. Remember, when we divide, we subtract exponents. So, 2 to the cube divided by 2 to the cubed should be 2. Okay, still the same base, but 0, because 3 take away 3 is 0. I think it looks better with letters. X cubed divided by x cubed. Well, if you subtract exponents, isn't that x to the power 0? Okay, so both of these have an exponent of 0. But look, here's the thing. What's anything divided by itself? Okay, think of this. 2 cubed is 8. What's 8? 2 cubed, 8. What's 8 divided by 8? It's 1. Anything to the power 0 is 1. I could just say that to you and you'd have to accept it, but that's why, okay? So, anything to the power 0 is 1. K to the power 0 is 1. Here it is in the book, okay? So, let's move on to negative exponents. That's just when you've got a 0 exponent. Let's have a look at this. Okay, now then, again, we are subtracting exponents. So if I say to you, what's b3 divided by b5, I'd like to think you'd say, right, what's 3 take away 5? Well, that's negative 2, okay? You're thinking, okay, I've got an answer. That's fine, that's good, okay? But supposing we want you to write that as positive exponents. Well, here's the explanation. Here's b3, here's b5. Right, cancel, 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 cancel. Right, can you see, you've got 2 b's left, but they're on the denominator, okay? In other words, this is what you've got. Remember, anything divided by itself, okay, anyway, I can write as 1. This is what the answer is, okay? If I just kind of write out the b's and then just cancel them out, okay? And that's why we actually have, these are equivalent expressions, I suppose. Here we go. That there, b to the minus 2 is the same as 1 over b to the positive 2. And the little secret is the shortcut. You just flip the thing upside down. I mean, look at this. If I do this, x to the negative 3, okay? You can write that over 1 if you want to. But what it becomes is 1 over x to the positive 3. And that's what you kind of have to remember, okay? So let's have a look at some definitions on here. And here it is from the book, okay? There it is, okay? You've just flipped the thing upside down. You can think of it like that. Some examples. Okay. I've done that one already. X to the minus 3 is 1 over x to the positive 3. How about some numbers? 5 to the negative 2. Now, some people think this is like, oh, it's negative 25. No, no, no. There's nothing to do with negatives here, okay? I know it's a negative exponent. What you're doing is this. 1 over 5 to the positive 2. Okay? There you go. That's it. From the negative exponent to write it as a positive exponent. Okay? Well, don't think I can finish that off. What's 5 squared? This is where the 25 comes in. No negatives there, is there? Okay, there you go. That's it. Okay, suppose you had this as a question. Right, just jump to the shortcut. I could say, right, that's x to the negative 3, because that's what 6 take away 9 is. But you say, it's going back to here, isn't it? That's 1 over x to the positive 3. Okay, and what you've got here is, think about it, you've got, this might take a while to do, you've got 6 x's on the top, you've got 9 on the bottom, 2, 3, 4, 5, 6, 7, 8, 9, and you go, right, cross off, cross off, cross off, cross, let's use an eraser, eh? An eraser. Right, 1's gone, 1's gone, 2's gone, 2's gone, 3's gone. We'll get this right. 4's gone. I could get lost here. Alright. Right, there we go. I've erased 6 on the top. I've erased 6 on the bottom. It's leaving with me 3 on the bottom. Okay, and the denominator. Don't forget to write a 1. So that's why that is that. Okay, there's the explanation. Okay, so that's negative exponents.